Today we will be using completing the square to solve these quadratics. Now this will be a little bit more difficult, and you'll see why when we're starting off this process. And so first step is to always isolate the constant on one side of the equal sign. So the first step I'm going to end up doing is moving this 4x, or this minus 4x, to the other side. So I'm going to add it to both sides. Next thing I'm going to end up doing is I always want to have the x squared term as just a 1x squared. You could get away with having a 4x squared or a 9x squared because that would be a perfect square, but it's a whole lot easier if we could just make it 1x. So I'm going to go ahead and divide that a squared term, the a term, by itself. So I'm going to divide every number there by 2. And so now what I've got is just an x squared plus 2x, and this all equals 35. So now it's a much easier problem. And so we're going to go ahead and factor or figure out what number it is that we have to add to both sides. So the next step would be to take this 2 and we take half of this number. So 2 times by a half makes 1, but then you take that 1 and you square it. And the reason is that the factored form is going to have that 1. It's going to be x plus 1 quantity squared. So you multiply the two last numbers, which are exactly the same, and so that's why we end up squaring it. And it makes a positive 1. So we go ahead and get 36 on this side, and we take the square root of both sides, and that's the whole purpose of this, is to make a perfect square here so that when we take the square root, it will cancel out, and we're just left with a linear problem where we just have a positive 1 here and x to the first power. Here we have the square root of 36. We've got two possible numbers there. It's either plus or minus 6. And so from this point, we just have one step, and that is to subtract the 1 from both sides, and we'll have our answer. So we've got 6 minus 1, which is 5, and then we also have a negative 6 take away 1, making the negative 7. So negative 7 and 5 are the two x-intercepts. Well, taking a look at this next one, I'm going to move this 9x over to the other side first. Just try to get the constant by itself. And then from there, the problem will work out. So I'm going to rewrite it. I like to have the x squared term on this side. So I'm going to move negative 2x squared minus 9x all equals positive 4. So I just moved these terms, just switched them on the other side of the equal sign, did the same thing with this 4. And then from this point, I'm going to get rid of this 2. Again, you want to always get rid of that. And this problem is going to be really difficult, so you just got to pay attention and follow along. So I'm dividing by negative 2, and what makes this one so difficult is that we have a fraction. See, x squared, and then we have a positive 9 halves x, and that's what makes this tough right there, that 9 halves x equals negative 2. You just got to really be careful with these fractions. As we go, we see we got to take half this number. And so 9 halves times by a half. I'm going to take half that number, makes 9 fourths. So right away, I know what the factored form is. The nice thing about this method is that you don't have to do a lot of thinking here. It's kind of a procedural problem. When we go ahead and take half the number, that's what goes inside the parentheses. So when you square 9 fourths, we end up coming up with the square of both the top and the bottom, which makes 81 sixteenths. So here's where people get a little bit confused because they don't like to deal with fractions. So here's why it was good to learn how to add fractions. See, we have 81 sixteenths we need to add to negative 2. But I can't add them right now because they don't have the same denominator. So I'm going to change that negative 2 over 1. I'm going to multiply it by 16. And so off to the side here, I'll go ahead and show what I'm doing here. I'm multiplying this by 16. I end up with a negative 32 over 16 plus 81. That's 81 over 16. So when I do that subtraction, real quick, I do 81 minus 32 because they're opposite in sign. I end up here with a 49 when I borrow from this 8 and change it to a 7. So 49 is what we end up with there, and it's positive. So we have 49 sixteenths is what I came up with. So we go ahead and take the square root of both sides. So that was the toughest part. That's where most people get tripped up. And then from there, it's all downhill. You see, when you take the square root, we end up with an x plus 9 fourths. And this all equals plus or minus 7 fourths. And at this stage, you should have those denominators exactly the same. So there's no more of coming up with common denominators. All you have to do is move that 9 fourths over, and the denominators, again, are going to be the same. So when we do that, I'll set it up right here. We have a 7/4, take away 9/4, which makes the negative 2/4, which makes negative 1/2. And then over on this other side, we have a negative 7/4, and we are taking away 9/4, which we end up adding because they're the same sign this time, makes negative 16/4, which makes a negative 4. So there it is, negative 1/2, comma, negative 4, the 2x-intercept. So that's why this problem is difficult. We could have factored this and come up with the answer a lot faster, but we got to have a method to be able to solve ones that you can't factor. So you're going to have the same situation on this next problem here. So let's go ahead and make a division here between these. And let's take a look at this next one here. I'm going to move how about the 3x squared back to the other side here. So I'll subtract it from all sides. And so when I rewrite this, and again, it doesn't matter which way you write it, I'm going to go ahead and put the 3x squared here, the negative 3x squared, and negative 20x, and this equals 12. So I'm going to divide by this negative 3 on all sides. Every number gets divided by negative 3. So let's rewrite what we've got now. We've got an x squared, and it makes a positive 20/3 x, and it equals negative 4. So from that point, we're going to figure out what half of 20/3 is. Well, that's easy. It seems like it's tough, but you're just you're multiplying that bottom number, that denominator, by 2. But before we do that, let's go ahead and cross-cancel a little bit. We got 10/3. It's able to reduce it, make it a little smaller, and that's what goes inside the parentheses. So it's x plus 10/3. So those are the two numbers that add to make the 20/3. So from there, that's a quantity squared. And this all equals, well, we've got to square this number. Square that 10/3, and that gives us 100 over 9. So we now need to multiply this negative 4 by 9 over 9. So off to the side, do this side work right up here. We got negative 4. Actually, instead of that, I'm going to write down negative 36 because I multiplied it by 9. So let's go ahead and do that. Negative 36 over 9 plus 100 over 9. And when I do that subtraction, I end up with 64/9. So that's the number that we get right here. From there, it's all downhill, as I said before, because when we take the square root, it's going to end up making two fractions with the same denominator. So there's no more of coming up with common denominators. So you'll see that in this next step here. We've got a 10/3 still. X plus 10/3 now equals plus or minus 8/3. So you see how the denominators are the same. So when you go ahead and move that 10/3 over by subtracting it from all sides, we end up setting up our problem right away and solving. So here we have a 8/3, and it's a minus 10/3, which makes a negative 2/3. And then we also have 8/3, and then we have a negative 8/3, that is, minus 10/3 equals negative 18/3. And so coming up with those numbers, negative 2/3, comma, negative 6. Got negative 6 by doing the division right here. So that's where that came from. Well, now we'll see where these problems are used. In geometry, when you're in that class next year, you'll have some problems that deal with quadratics, and they'll be area problems just like this. So let's take a look at this. Common geometry problem you'll see next year. A rectangular garden has an area, so they give us the area. Area equals 432. And it's a rectangular garden, so let's just draw a little picture of what we've got here. And it says the length is, and this is the length right here we'll call, the length is 2 more than 3 times the width. So there's the width. The length is means equals 2 more than 3 times the width. So 3 times the width plus 2. That's what 2 more means. It means 2 plus. And so they want to know what is the length and what is the width. What are the dimensions? And so we'll go ahead and substitute our numbers into our little formula here. So remember, the formula goes 432, that's the area, equals the length, which is 3w plus 2, times by the width, which is w. And so from this point, you're just going to distribute that w over these numbers. And so now we have 432 equals, and this is a 3w squared plus 2w. So we're ready to solve. And so the way we're going to solve this is divide by 3 first. Always get rid of that a term. And let's see if 3 goes into this. This makes 7 plus 9, and let's see here, 3 does go into 9, so 3 should go into this number as well. So 3 into 4 goes 1 time, 3 into, with 13, with 1 left over there, so 13 now. 3 into 13 goes 4 times with 1 left over, so put a little 1 there. 3 goes into 12 4 times. So 144 equals, and then we have a w squared plus 2/3 w. And so from that point, we are taking half of this b term, so half of this number right now, and 2/3 times by 1/2. The 2's cancel out, so we're just left with 1/3. And again, the nice thing about this is we know what the form is for the factored form. It's going to be a w plus 1/3 quantity squared, except it's not 144 here, so I'm going to erase that part. It's what I get when I add 144 and the number that I need to figure out what it is that makes that a perfect square. So let's go ahead and figure that out from here. 1/3, we've got to square that number. That gives me 1/9. So I need to add 1/9 to both sides, 1/9 to the 144 as well. So when I do that, off to the side here, I'll just go ahead and write down 144 over 1, and I'm going to multiply this by 9. So let's do that real quick. So 144 times by 9 equals 1286. So I'm doing this right here, plus 1/9, and so I multiplied this by 9. I got a 96 over 9 plus 1 over 9. And so when I do that work, I end up with a 1297. So this one's not going to end up working out as smoothly as the other one did, but we'll see what to do in just a moment. And so here's our number, 1297 over 9. And so we'll go ahead and take the square root of both sides. And so when we do that, we're left here with a plus or minus the square root of 1297. That's not a perfect square, and it's over 3 now. And then equals, we've got a w plus 1/3. So we're going to end up subtracting that 1/3 from both sides. And here's what we get. We'll take away that 1/3, take away the 1/3, and we've got this now. We've got a -1 plus or minus the square root of 1297. This is all over 3 equals w. Now, if you wanted to leave your answer as an exact answer, that's what I do. But for right now, I'm going to go ahead and take that 1297 and figure out what the square root of that is. A good approximation. So a good approximation of this is going to be pretty close to 36. So I'm going to just say about 36 over 3. And so I go ahead and do some work there. So I've got two different answers here. I've got -1 plus 36 makes 35/3. And then I also have a negative, actually that's going to be a positive 35/3. And I have a negative 37/3. Now, which one are you going to use? Well, we don't have negative answers, negative widths, so we're not going to use that one. We're going to use this one here, this 35/3. And so what we need to do from this point is figure out how many times 35 goes in there. So 35 divided by 3 gives me about 11.7. So I'm going to say this width is about 11.7. Well, how much is the length? Well, all you're going to do is just take that length there, that 11.7, plug it into this formula. So you have 11.7 times by 3. Times by 3, that's right, because we have the 3. We're going to triple this number, and then we are going to add 2. So when I add 2, I'm tripling this number, right away I know that's going to be 35. And then plus 2 gives me about 37. So that's an approximation again. So the length is about 37. And what are the units? Feet. So we'll stick those in there. So about 37 feet and about 11.7 feet as well for the length. Well, ran out of time for this next problem. I'll finish this one up on part 2. So check that out.